So hi, Joe, or Joey. Joe is right.
Joe.
Joe, what was your first computer? It's the most important question, of course.
It's a Hewlett Packard 386. I don't remember the exact model. A friend of mine had a Tandy. I remember playing Joust on that thing. Another friend, actually, what got me into programming, a friend of mine, his father worked at IBM, and so we spent a lot of time on his IBM PC. But the first one I had physically that I, quote, owned was a Hewlett Packard 386, I believe.
And what you did with it?
I broke it many times. I installed Linux on it and completely hosed the boot partition.
Linux?
Yes. Yeah, I had.
So you were not about gaming.
I was a little bit, but no, I really wanted to do Linux stuff. It was this 1993, I think. I had Slackware Linux, and I totally broke the computer, and I had to replace the hard drive myself. And I learned the hard way what a boot partition is.
The same here. So I had to run Linux and Windows NT on the same machine, and there was a Linux loader, and I broke it several times because accidentally. I remember, the DD command, and there was and I confused the EF with the other one, so I overwrote the master boot record, which and then everything was broken. And then I bought a book because the master boot record is actually a small thing. I tried to repair it, but it never worked actually.
Yeah, it's the same thing. Lilo, the bootloader. I remember that. That's what I was fiddling with.
Yeah, exactly.
Well. Yeah. And then we had a family friend who supposedly knew how to fix it, but then just made things worse. And I took matters into my own hands.
Yeah, I think in Lilo it was required, to edit the master boot record to have a dual boot, right? This was the problem back then.
Yes, that sounds familiar. I think I was trying to dual boot it, so I still had Windows and I could boot into Linux, and that's where things were horribly wrong. Yeah.
Yeah, perfect. So amazing. So I was a little bit earlier than you, but I had the same problems. And I think even I used Slackware and then DLD, which was German, Deutsche is German Linux distribution, and then SUSE, and then stick with Red Hat actually until now. So interesting. So you didn't play games. So you just why you actually try to install Linux on an HP box?
I was misguided. No, I actually. My first computer experience, I think, was in school. We had Apple IIs, and I learned to love Logo, with the little turtle guy.
Yeah.
And then I was into, Dungeons and Dragons kind of stuff, and somebody told me, hey, you can play textual Dungeons and Dragons, MUD, multi-user dungeons. And so I got really into MUD in like the early 90s. And so it was games. It was just text-based, not graphical.
Okay, and your first computer at home, was it like C64 or?
Yeah, no, this was the HP 386. I think it was 386. Okay. It might have been 286. But it was like, I don't know, 13 megahertz or something. It's like really slow.
So, but if you damage the Windows box and you install Linux, I think this is how we started programming, right?
Exactly. It got me, I actually ended up compiling some stuff from source, and my first programming language was C. And so Linux was a great environment. If you were doing C programming, all you needed was, VI or Pico or one of those editors back then.
So same here. So I started with C and then did a little bit C++ because there was the book from Björn Strostrup. Was really excited about that, and actually GCC and G++, I think, right? So there was GCC was the first compiler and G++, I think, or C++ even. This was like the post processor, whatever, right? So he compiled CC first and then C++, exactly.
Yeah, I think Seafront was that the name of it, but I remember, it was all GCC based when I think it was GCC back then.
Yeah.
Yeah, I didn't really understand much about make and config files and
no make. But I was fascinated by C in and C out. I really like that, And operator overloading was big back then, so huge for me.
I do have to say, like, the 13-year-old mind, or 12 or whatever, however old I was, like trying to grapple with the concept of pointers. I think that was quite confusing for a long time. And then finally, I just got it one day.
Yeah, with ampersand and whatever. So what was your first program you wrote actually on your machine in C?
I didn't start with Hello World, because I had a little book. I had the Kernighan Ritchie book, the standard C book. And so I think I just typed in a few of those programs. Really, the first thing was Circle Mud. I think it came out in 1992. It was one of these multi-user dungeons. I started with that because there was a lot of content. You could actually just change the content. It was like tables in the C code, hard coded in there. So you just go change the tables, recompile, and then wow, I just made a change. And then I started getting a little more sophisticated, and I actually ran my own BBS and my own MUD for a while back then. So that was the first thing. I don't know, the first significant program. I remember trying to create 3D simulations. So I was really into like trigonometry and figuring out how to represent 3D worlds, and got into games like, Doom and, some of the kind of 3D, Wolfenstein 3D even before Zoom and some of those. But yeah, I can't remember the first significant program I actually created from scratch.
Okay, so you were fascinated by or inspired by movies, I suppose, right? Star Wars or whatever. So with the 3D idea, or just by games?
I like figuring things out. And I was kind of like, hey, how do you actually project a three-dimensional world on a two-dimensional screen? For some reason, I was just really fascinated by that problem. And I didn't actually know there was like trigonometry and calculus and all these things. I just kind of tried to figure it out from first principles. And I realized, oh, this is actually really complicated.
Okay. And one question, what I'm curious about Hello World, because I remember at the university time, someone wrote on the blackboard, Hello World. And I asked, why are you writing this? What does it mean, Hello World? And he said, okay, this is like, what you usually do if you write something in a language. Like, why? So back then, there was no concept of Hello World to me. So was it actually Hello World or something else in your case?
I think it was Hello World. I don't know. It's like chapter 1 or 2 of the KNC, KNR book. I think it was Hello World. I'm pretty sure, but I could be mistaken.
Because in my books, there was no Hello World. So I missed the entire Hello World, idea. And it was like, 5 years later, I saw the first time Hello World. And I said, okay, why are you saying Hello World? What is it? And it's okay. Interesting. Okay. So what happens then?
My career, you're saying?
No, I mean, what I'm curious is, your first program was like, Hello World or something similar. Then, 3D. And what happens then? So, I mean, I'm really curious what. And by the way, if you started with this 3D modeling or programming, you still played games, or was it just game were over and you were just interested in serious computer stuff?
There's still some gaming. I was a young, early teenager back then, and at some point, I think around Windows 95, I decided, okay, I'm gonna actually use this graphical user interface for some things. So I think I got a second computer because I learned that dual booting was tough. And then I started learning like Visual C++ at that time. And then I realized, wow. So it's funny. The Hello World for the Visual C++ book is like 100 lines of code compared to standard C, because you had to set up like the message pump and deal with like H-wins and all these crazy things. And I didn't know why everything was uppercase in Visual C++, whereas it was lowercase. And now I understand it all. But back then it was very confusing. I started doing more graphical things. So I did actually start building some graphical games at that point. On Windows. And, modding Doom and Quake was a thing back then, so I was kind of really into that as well. So that took me through most of my teenage years, just, playing with, Windows 95. I did actually eventually start doing internet stuff very early on, when you had to like dial into these places like CompuServe, I think it was called, stuff like that.
Which modem? Robotics?
I remember my first modem was 1400 baud modem, but I don't remember the brand.
Okay, because robotics was a cool name, so this is what I remember. I really like robotics. And it was just the first one, my modem was 33.600, I think. There was such a thing, right? It was the speed, right?
Yep. I remember upgrading to 33.6, and it was like life-changing. I actually ran a BBS out of my house, so I convinced my mom to install a second phone line so I wasn't constantly using our voice line for the BBS traffic. But it's the most exciting BBS in the world. You could have one user logged in at the same time. Actually, two, because I could be logged on as well.
Okay, so it was almost concurrent programming sometimes, right?
Yes. It's like the lamest social media platform in the world. You can have two active users.
Yeah, exactly. So and cold start, I guess, right, with the modem, because it took a while until it was active, right?
Yeah. Well, it's funny too, because it was in my room, and suddenly, like 5 o'clock in the morning, suddenly the modem just starts making that noise, right? And I'm like, oh, I guess somebody's connecting to the BBS.
What happened then? So you started program. So you what is the next programming language, or you stick with C and low-level programming? So I'm just curious to know about your trajectory.
Yeah, so I started a consulting company around 95, 96. So internet stuff started showing up on all the billboards, and it was like clear, like, oh, this is going to be a big deal. And so, a lot of companies were looking to, quote, get to the internet. So I started a consulting company and helped a few companies to create websites. And so I was doing active server pages, and I think this is the first time I might have been introduced to Java, because I was looking at like servlets and CGI. Yeah, I think it started with CGI because you could do C-based CGI handlers, and then I quickly moved into ASP and servlets because those were easier. And different clients had different, programming languages they wanted to use because they had in-house expertise. So I did that from like 95 to 99 thereabouts. I have to admit, I wish I could do it over again, because I should have walked away making a whole lot more money than I did, but I was a teenager and had no idea what I was doing. But it did give me the entrepreneurial bug. You do a little bit of sales, a little bit of customer support, a little bit of programming, kind of get that end-to-end experience, which was pretty fun.
And you remember if you did servlets, which server it was, or servlet engine?
I don't remember. I know it was probably like 99. I was using like JBoss, I think, if I remember correctly, but I don't know how I get started. I can't remember. Yeah, exactly.
So funny that you stick actually with ASP and Microsoft world, because you came from Linux, to the Microsoft world is like complete different world. So I stick with Linux, and I also bought, student version of Visual J++, Visual C. There was like, a box with 3 programming environments. But I didn't like that because it was completely different and like, strange for me. It was like, I think it is impossible to understand what's going on. And and you stick with in Microsoft world. So why that? So I mean, this is, if you started with Linux, how you managed, to be successful on Microsoft platform?
Yeah, it's a great question, because I remember my mind was blown the first time I realized people had to pay for their compilers. Yeah. I was like, what? I get great compilers for free. Why do I have to pay for it? Thankfully, so the reason I did it, one of the clients that I actually worked very closely with was a tea company, and they were trying to reinvent everything, really embrace e-commerce. And after we did this project, they did like $3 million in revenue on their website the first year. So it was very successful, but they were a Microsoft shop. Actually, they were using Borland. What was their forms package? I forget the name of it. But they want. Say again?
Delphi?
No, it was. I forget. I'm blanking on the name. But they wanted to move everything to Access, Microsoft Access, with Visual Basic Forms, and eventually I convinced them to use SQL Server because Access wouldn't scale on the back end for the website. So that kind of pulled me into the Microsoft world. Before that, I really wasn't interested in sort of Microsoft technologies, and that's how I got started.
So interesting you mentioned CGI and servlets, because in my case, I was asked to do CGI, but I had no idea. I thought, CGI you have to use Perl, and I couldn't understand Perl. For me, it was like it was ugly. And the only thing I knew was Java. So I waited until servlets become available, and instead of using CGI, I used servlet. And I know, and back then, as you remember, CGI was slow because you had to start the process and was not very secure. And Java was, to say, faster actually because it was thread based. So this was actually my strategy, to get projects, because I say, okay, I only understand Java, but I can sell Java better, because it was actually true. You can. And servlets were actually back then pretty productive, I would say.
Yeah. I think it was great. It was, if I'm remembering correctly, serving up HTML, you ended up like kind of hard coding a lot of HTML in your response code in Java, and then JSP came along, and I definitely I think there was some Apache projects that predated JSP, like struts. Am I remembering that correctly? But JSPs were great.
Yeah. Struts and JSP were the same. But the company who invented JSP was actually ATG, and they called it JHTML. And this JHTML was like a template language, and then JSP came from Sun, which was based on the JHTML. And the funny thing is, what I recognized back then, what I find out is that if you run the JSP the first time, which is slow, but it gets recompiled, you get the servlet. So if you look at the servlet, it was like the inverse JSP, because it was whatever was free floating in JSP was hard coded inside out print line in a servlet, so which was actually still remember that for some reason. Interesting. So you did also some JSP. Mm-hmm.
Oh, ATG. It's funny. We'll talk a little bit about my first real enterprise job was as a Java developer. And we partnered with ATG very closely. I think it was Art Technology Group, which was in Cambridge, Massachusetts, because I'm from Massachusetts. And my second formative startup experience that stands out in my mind happened there. But I'll save that story for later in the timeline. It's kind of a sad story, but it definitely sticks out in my mind.
Okay. Yeah. ATG Dynamo, they were also bigger in Germany, and there was some, this is why I remember them, and they were very active actually, and achieved a lot back then. And so you did some GSP and Struts, I guess, and JBoss. So JBoss could be right. So I think JBoss was a little bit too early. So what I suppose it was the Java web server. It was the first one. Then was a WebSphere, and JBoss I think started with 2000 around, and it was bigger 2003, a little bit later. But by the way, on the podcast there was also the guy who created actually JBoss, which was also funny conversation with him. Mark Fleury is his name, and we are talking about how JBoss happened. So you did some Java work, and you stick with Java then, or moved back to Microsoft, or what was your impression about Java and Microsoft? Because it's interesting. So for me, I just stick with Java, so I had no experience with ASP.NET. So if you compare the both ecosystems back then, were they similar? What do you prefer more? Just curious.
So honestly, I was dragged kicking and screaming to use Win95. I only used it because, actually, what was it? Lynx was the browser, and suddenly, most websites just wouldn't work with links anymore because people went crazy with images and they wouldn't put useful alt tags. And so I felt like the whole industry just forced me to move to a graphical user interface against my will. So I really was not a huge Windows ecosystem kind of guy. And so from there, I did take some college classes. I ultimately decided to just jump straight into the workforce and skip a stage. And so I ended up at EMC as a Java developer and spent 4 or 5 years just being in the Java ecosystem 100%. I ended up at Microsoft after that, but I was definitely not sort of a fan of the Microsoft ecosystem back then. I looked at things like J++ and some of the Java products that Microsoft was putting out. They seemed like just poor approximations of the great tools I had that were coming out of Sun at the time. And I remember at EMC I had a Spark station on my desk. I was really hardcore Java for multiple years.
Okay, cool. This is what I didn't suspect it, actually. I thought, you were just, didn't like Java for some reason, but interesting. I was also a huge Sun fan back then. I don't know why. I just like Sun. So many of the developers, and this was hard to explain. Sun was like a really interesting company because maybe they were not about to earn money, This is why more like a hippie company who I really like, the attitude. So, okay, just innovate, and but it was of course not that successful. But still.
Yeah, it was the first. I was a huge fan of Sun, and honestly, the Java community was the first time I experienced what a community is like. With computer, we talk about communities all the time, like the Python community, the infrastructure as code community. That was the first community that I felt part of. And, going to conferences, it felt like there were a lot of exciting projects. There were companies popping up left and right to do J2EE servers and things like that. So it was an exciting time.
Yeah. And the conferences were huge. I don't know whether you remember the Java One. It was like, it was a great experience back then. And after the Java One, I would say, or after the Java One, starting maybe 2006, there were more and more conferences all over the world. But the Java one prior to 2006, it was actually a huge experience for me. So to me, it was like, there were like 25 to 30,000 people. And there were all the hotels, Moscone West and North, I think, was completely closed. So it was crazy. You attended Java one back then?
I never attended Java one. I was mostly going to smaller kind of boutique
Okay.
conferences, meetups, and again, I was in Massachusetts, so there were meetups in Boston, and I can't even remember any of the names of them. I just remember I went to a bunch of them, and I always enjoyed listening to the kind of thought leaders in the Java space talk about things. And I mean, it was fun. It was, again, I was young, early in career, but it's the first time I really felt connected to a community.
What happens after EMC? So you mentioned already Microsoft.
Yeah, so it's funny because I was sort of on the central architecture team at EMC that was working on a lot of the shared libraries for reliability across a lot of the products. And they had products in C, some stuff in Java. They had a lot of embedded like microcode stuff too. But this .NET thing started coming out, and we did have some desire to run EMC software on Windows. And so I started looking to .NET, and the history of .NET is kind of interesting. A lot of it comes out of there was the Sun lawsuit with Microsoft, and .NET sort of came out of that, rising from the ashes, let's say, of some of the Java products they had. And there was a lot of things that I liked about it, and so I started digging into the .NET community, and I found it very similar. It was super early, right? Because when did .NET launch? I think 2000, 2001, something like that.
Yeah.
And so I sort of became an internal champion for .NET at EMC because I thought, hey, a lot of the things we love about Java, we can accomplish with .NET as well. Higher level programming language, a lot of similar features, great libraries, the ability to share and reuse libraries. And so I became an internal champion, started going to some of these conferences, met up to some .NET experts, and they were hiring on the team. And it was early days still, and it seemed like a great opportunity to get in on the ground floor, building out the .NET platform, helping with the C# programming language. And, it was a hard decision to leave the Java community behind because, again, that was my background way more than Windows and Microsoft. But there was a lot of excitement, and it was really fun, and I connected with the people there as well.
Interesting. So I would say it was around 2002 as .NET happened. In Germany, there is one called Fraunhofer Institute. It's like, so scientific, I don't know, or how to call it, an institute, actually. They do lots of research. And I don't know how, but I was invited as a Java guy. And someone from Redmond, he was one who created the .NET runtime, was invited. And we had a kind of a fight. So there was like Java versus .NET. And what was really interesting, that the Redmond guy, he used VI and Emacs to write the .NET Core. So I was stunned the very first time. It's like, you are from Microsoft and you're allowed, to use VI or Emacs, and say, okay, we don't care, we do whatever, it works. And that was like, funny, because for me it was like .NET was complete loser back then from my perspective, because .NET came after Java and we had already everything. So whatever I said, it was either it was expensive or not available. So I would say the entire idea, .NET versus Java, was not that great back then. But I was stunned actually that the engineers at Microsoft use Linux, and he was completely into the core of the virtual machine of .NET, and he used VI, Emacs, and we had a great discussion. So this was the first time I changed a little bit my mind about Microsoft back then.
Yeah, it is. I don't know if it's the same person, but actually the garbage collector. There's one phenomenal engineer on the team who I get the pleasure to work with over the years. He's amazing. He wrote the first version of the garbage collector for this common language runtime, which is basically the JVM equivalent. He wrote the GC in Lisp over an extended weekend, and then wrote a transpiler from Lisp into the subset of C that they use for the implementation of the runtime. So I wonder if it was the same person.
Yeah, maybe. Was he German?
No, Patrick Dessoude. He's actually, I think, French. But
okay,
Peter Solich is from Germany, and he's a great engineer who's been there since the start as well. So I wonder if it was Peter.
Maybe
he's German. Yeah.
It could be Peter. Yeah. And by the way, it could be somewhere in Sun they had Bill Joy was the same story. Like Bill Joy wrote on weekend everything. So maybe the .NET Microsoft had similar engineers like Bill Joy. Lots of tales about Bill.
Oh, I was just gonna say that was one of the things I'd never experienced before. Was just these phenomenal engineers, and I'm so glad I went to Microsoft because you can find phenomenal engineers at many companies, but the CLR back in those days was just a concentration of some of the best engineers I've ever worked with in my career and probably ever will work with.
And then you left Microsoft, so you stick, with you were evangelist back then for .NET, right?
So I joined as a product manager, and then quickly realized that
Okay.
I liked writing code too much to not be an engineer. So then,
Yeah.
I was there for 14 years or 13 and a half years. And so I wore various hats. Most of the time there, I was managing engineering teams.
What happens then?
Well, so I worked on a lot of products there. I worked on .NET in the early days. I worked on a research operating system in MSR that was all about really, reimagining concurrency. And basically, imagine we built a concurrent type memory safe operating system from scratch. And that was a great project. I was running the languages groups, parts of Visual Studio, some of the Azure tooling. So I had, I spent a lot of time on C++, which I never expected in my career that I was going to, manage the C++ group, but that was actually a really fun time before leaving. But really what struck me is cloud has really changed everything about how we build software. And yet, from my perspective, running languages teams, it really hadn't changed much. I spent most of my time in the 2000s working on multi-core, how do we bring task parallelism and data parallelism. Got to meet Brian Getz from the Java community as part of that, and Doug Lee as well. And so a lot of good cross-pollination there. But then, the cloud, there's a lot of similarities where, we invented async programming and task of T and, future of T and all these constructs in the 2000s. But we really haven't done the same for cloud computing. And to me, this is finally the era of distributed computing. So decided, hey, going to leave Microsoft and start a company to go try to really make the cloud, 100 times easier to use for developers. I mentioned early in my career, I had that startup bug from, starting my own consulting company. And I really wanted to get back to that. So literally every year at Microsoft, over the holidays, I would say, okay, it's now the year. And I was having so much fun. It was never the right time. But then, this opportunity kind of presented itself. My co-founder was ready as well. We forgot about the art or ATG story as well, which was
exactly. I was waiting. And before we cover the ATG set story, were you also involved in the project Longhorn? This was like the innovative, operating system or something different.
I was. My co-founder was as well. Yeah, that was an experience. Yes, I was right in the center of that because I was actually I was helping to manage some of the WinFS. We used to call it Avalon and Indigo, but it turned into Windows Presentation Foundation, Communication Foundation. So yeah, I was right in the middle of that. That was a learning experience also.
Okay, now back to the set story, unfortunately, about ATG.
Yeah, so we'd used a variety of app servers at EMC, but we were working with ATG on a strategic partnership between EMC and ATG. And so I went on site. I was at ATG every day for months, and it was amazing because the people there were fantastic. The technology was great. So much Java love in the air. And then one day in the middle of a meeting, people got pulled out of the meeting, and I wasn't allowed to join. I thought, this is bizarre. And they had an all hands, and they let 80% of the company go that day. And so I don't know exactly what had happened, but clearly that was, they had fallen on hard times. And that was a good lesson learned for me because, eventually starting a company, you always have to be prepared for, you can't run out of cash. That's priority number one, with startup. And I remember, they used to have foosball tables and free snacks and free drinks. And then next time I was there a week later, all that stuff was gone. So that was a sad story because it was a great team, and I love my time with them. But it was definitely a formative experience that stuck in my mind.
Yeah, for me it was the same because I also experienced, the 2001 after the how it's called new economy, right? So the golden days of new economy, and this is why I'm still a singleton. So I'm freelancer since then because I say, okay, I know the business is not right for this. Too much risk. You can focus on technology. Maybe it's more fun, and it also works, right? So this is not you cannot compete with larger companies, but you have still fun and still working. So, okay, interesting. So you started a company. So what was the name of the company, and when you started a new startup?
Yeah, so I left Microsoft September 2016. We had a vague notion that we want to make the cloud 100 times easier to program and didn't know exactly what that meant. Turns out we ended up on it, building infrastructure as code in your favorite languages. We'll talk a little bit more about why that's exciting. But it took about 6 months for us to figure out exactly what we were going to do. So March of 2017 was when we officially incorporated the company and got started. Really got started relatively slowly. Took over a year to build the initial version of the platform. But yeah, that's sort of the timing. And it was a little scary, quitting your job after 13 and a half years without knowing exactly what you're going to do. But I had a great co-founder, Eric, who he actually created Visual Studio at Microsoft and managed the SQL Server teams and managed Microsoft Research for multiple years. And he had definitely, we knew we would work well together. And we knew we were sort of a shared mind about how exciting a future we could build.
What is the name of the company?
Oh, right. Pulumi. Pulumi.
What does it mean?
Yeah, so it means broom in Hawaiian. It turns out it's a tribute to a good friend of mine and mentor, Chris Broom, who passed away, unfortunately. He grew up in Hawaii, so it was kind of a funny... In fact, his actual name is Broom, but people mispronounce it Broom. So it was kind of a funny thing. And he was advising the company. He was actually one of the early engineers on .NET as well. Paradox, Borland Paradox. That's the one I tried to remember that T company was using.
Okay.
Because he was an architect on Paradox at Borland, but he was one of the original engineers on .NET. He was an amazing mentor the whole time. He was advising us on Pulumi right up until the end. And I was able to tell him the name before he passed away, and he said he hated it. It reminded him of the word baloney, which isn't a good association, but I told him, Chris, we're going with it anyway. So there we go. And it's 6 letters. Pulumi.com was available. It was fate.
By the way, I don't know how I found Pulumi on early days, but it was suggested by someone in a forum, and they say, okay, this is great. This is what I remember, I never tried Pulumi hands-on because I usually use on AWS CDK and on Microsoft the ARM templates usually and Bicep. But this is my background. But when I heard about Pulumi so far, it was actually positive. So this is my feedback, what I found so far. So this is what I found interesting, and even more interesting, of course. Now you. You eventually also supporting Java, seems like, right?
Absolutely. Yeah, it's interesting. When we started, CDK didn't exist. Like the best of the best was, Terraform with DSL. And for us, we wanted to bring the cloud closer to developers, make it more familiar to them, and also give infrastructure teams great software engineering tools. And we decided, we just spent decades building amazing developer platforms. That's the thing that got me out of bed in the morning, is how to make developers productive. Why wouldn't we just leverage all those great IDEs, sharing and reuse, everything we know and love, and just apply it to this domain? And, about a year after we got started, CDK came out, and, I would say that this is becoming more popular in the industry. And so it's really transformed very rapidly.
Yeah, but back then Terraform was already available, right?
That's right. And
why you didn't like Terraform?
We didn't even start with infrastructure as code. We actually started thinking, should we create a new programming language? And my experience from the 2000s with multi-core was kind of informative, because we created a bunch of programming languages back then. We're like, async is too hard. We need a new language. Turns out at the end of the day, all you needed was task of T, future of T, async await in the language. And actually that was good enough. Rust has taken it even further with concurrency safety, but we didn't think, hey, you need a new language. But what you did need was a resource model for the cloud resources. If you think about how we interact with the operating system, you create files, you create these things that are allocating resources under the hood, but you don't go configure them entirely separately. You're just writing code, and there's an object model and a lifetime for these resources. That's part of how the operating system process model works. And we're kind of like, what if we had that for the cloud? And that led us to infrastructure as code. But you look at, Terraform's DSL, after we've launched, they've since added for loops and crazy conditionals, but it's the level of complexity and expressiveness and the idea of sharing and reuse just seems so important to this domain that not leveraging general purpose languages just seemed like a bad idea to us, and aesthetically, it didn't speak to me.
This is exactly also my experience. This is why I wanted to ask you. I had I did actually Terraform a lot, and what stuck me, even a for loop is crazy in Terraform. So I have, if I have, to create subnets in different AZs. I remember I had, to iterate first and it was like a completely unnatural thing to do. And if statement was even worse back then. I remember if statement was like, if the counter was 0, there was
Yes.
true or false. But something like this, it was like, so why? I mean, after 20 years of Java, now we got this. But what really I wondered is why no one complains. Because everyone's Terraform is great, and I try to do something interesting, and they say, okay, but it's great, but this is unnecessary plumbing. This is like why? And the next thing was in Terraform, which really was even crazier. The modules were not that easy to share. So if you have the Terraform module and you wanted to make it shareable, so in Java we had Maven repository, whatever, this was not an issue. With Terraform, the question is where to store the thing, because everyone worked with a local state. And for me, there was actually no way, in the project. I even saw, someone launched everything on EC2 machine, and developers have to log one after another, to deal with the shared state. So, okay, but for me, it is like crazy. This is absolutely. So this is why I look at the entire infrastructure as code like Terraform. I couldn't understand why it is successful. So then CDK came out, or even CloudFormation. So CloudFormation, of course, this JSON is hard, but at least the state is stored in the cloud from day one. So I mean, this is no one speaks about that, because at least you have the entire state in the stack, and you can log into the console. You can delete the entire environment locally, and you can still deal with it. But and this is a huge difference. But I never heard that actually someone says if CloudFormation is compared, let's say, with Terraform, the state is like never mentioned, right? Which is crazy to me.
Yeah, it's a great point. So I think there are a few reasons why we ended up with Terraform. And on the state thing, when we built Pulumi, we modeled it much more like CloudFormation for that very reason. Like managing the state is so complex, and we talked to so many people that got it wrong. They accidentally made a merge conflict mistake when they resolved it, and they torched their production environment, or they checked in a secret. Or whereas with CloudFormation, many people say CloudFormation doesn't have state. Oh, well, of course it does. It's just managed behind a service. And so that's the approach we took, because I agree with you. It's kind of a subtle point, but it's a really important one, I think. And then, like on your previous point on why...
Joe, also, the problem is the secrets. You actually, in larger companies, you cannot just check in the state to Bitbucket or Git, because it is scanned. So you cannot do this, because all the credentials are inside. So what you need is from day one a solution to the problem. So you have to agree with colleagues, should we store it in S3 or whatever? And in every project, I always started the discussion with state, and they say, okay, we don't know what to do, right? So for me, it is I don't even know, Pulumi, you said you also storing the state globally, which for me makes absolute sense. If we have the cloud and everything's in the cloud, why the state is on my machine? I don't get it. I mean, for me, it is like conceptually, it's completely wrong idea.
Totally agree. Yeah. And just on your quick point on your previous thing, like I think the reason we ended up with Terraform was three things. One, when Terraform started 10 to 12 years ago, infrastructure was much simpler. You had 2 virtual machines in a database, and like maybe your config was like 20 lines, right? Or maybe worst case 40 lines, 50 lines, but it wasn't thousands of lines like you see today. The second was, I think the silo between IT and operations and developers was pretty strong, right? Like developers very seldom went and configured. Just like back when I was a developer, we didn't write SQL. Like we had DBAs to do that for us, right? But like nowadays, developers are much more hands-on with the infrastructure. I think the third thing is, every domain-specific language ends up growing up to be a general-purpose language eventually, if if left to its own devices, because you need for loops, you need these things, and you bend and twist it to the point where, hey, why didn't we just start with a general purpose language to begin with? And I think that's where Terraform is.
Exactly. And I also have a suspicion that so I think why Terraform is successful is because it supported everything, right? So not only the cloud, but also OpenShift. And what I heard a lot is, okay, we only have to learn, Terraform once, and then we can apply it to different, how to call it, environments. But for me, I would say for a programmer, Terraform is actually trivial. If you look, you can learn it very quickly. So I don't think you have to invest weeks to understand Terraform. I mean, in 2 days you could be productive, and and also then there's a misunderstanding in management. Then you can have a hybrid cloud with Terraform that is portable, which is not true at all. So I mean, there's nothing portable in Terraform because Azure looks completely different to AWS. So I wouldn't even try to somehow to synchronize both. But I heard a lot. We have a multi-cloud environment, and therefore we have to use Terraform. But yeah, I mean, if S3 is completely different to table storage or to blob storage, and I mean, there's complete different attributes, complete different outputs, and I mean, forget it, right?
Yeah, and I think the thing for Pulumi that we stress is, you can standardize on one authoring language and experience and workflow for deployments, but we're not going to hide what makes the individual clouds themselves and what makes AWS special. Yeah, that's where people often, when they do multi-cloud, that's where they go wrong. They try to create an abstraction that hides all the interesting details, and they spend more time building the abstraction than they would have just building a great application on the cloud.
Yeah. So now. In which programming language Pulumi is written? So I'm really curious. I suspect, mix of Lisp and maybe Ruby and.
If it was written 10 years earlier, it probably would have been Scheme or Lisp or something like that, or Haskell actually. Fun fact: I do have a Haskell tattoo, but that's between you and I and your audience now, I guess. But
no one will. Yeah, we'll cut it out. I thought at least a Duke tattoo or something, but Haskell a little bit disappointed. I thought you had a nice Duke, tattoo.
Honestly, a Duke tattoo would be pretty cool. Maybe to commemorate this launch, I'll have to get one of those. It's written in Go. I think Go. Around the time we started, we've got Kubernetes, we've got Docker. Go is sort of the lingua franca of like a lot of the cloud tools. And, we're an open source project. It was kind of important to us to fit in with the ecosystem. I have to admit, I do enjoy programming in Go. There's a lot to like about the ahead of time compilation model. You got a single binary for deployments. It's sort of like Python and C had a kid together or something, But it is a strange language too. But that's what we wrote it in. But honestly, we support, what are we now, like up to 7 languages or something? So we actually host the native runtimes. So we have a plugin model. So actually, we have SDKs in lots of languages.
Yeah, but how it works? So you have the runtime in Go. The state is where? In the cloud, or where you can? What is the different conventional? I would say. What is the opinionated experience of Pulumi? So if you would start, let's say, AWS project, what would happen then?
Yeah, so the opinionated experience, the default out of the box is that you create a cloud account, and you can store your projects. We call them stacks. So you might have a lot of development stacks, test stacks, production staging, production East Coast, production West Coast. It's sort of like GitHub. How GitHub gives you repos, we give you projects and stacks, but the state is stored remotely by default. So it works a lot more like CloudFormation than, say, Terraform. That said, if you want to, you can opt out of that and you can store your state however you want. You can put it in an S3 bucket. You kind of get that Terraform experience that we talked about that's error prone, but some people need more control or maybe they don't trust us yet. But that's the default. We just want to make it as easy as possible to just get up and running and do the right thing. Secrets are built in, so encryption is automatic. There's a lot of good things about the hosted service.
Okay. And the state we store where? At Pulumi servers or?
That's the default, yeah. In our servers, encrypted, in transit, at rest, private in your account. So you sign up, you basically...
So this is, so it means it is open source? Even if we use the open source edition, I could store the state on Pulumi servers?
That's right. It's free for unlimited individual usage. We also have free tiers for teams if you want to collaborate. But yeah, the default is it's all open source. So if you want to go offline without the service, you can, but you download it and it will say, hey, where do you want to store your state? If you want to store it in our service, hit enter. It's free, it's easy, and most people do that.
Yeah, interesting, because this is actually the commercial model from Terraform, right? Because if you would like to have the Terraform registry, that's the Enterprise Edition. And it seems like it is free in your case, right?
Yeah, and Terraform, after we launched, they kind of launched a Pulumi-like service, the Terraform Cloud, that you can use as well. But it's not the default experience. And so like 2/3 of our community use our service because it's easy, it's secure, it's you don't have to worry about it. I think with Terraform, only 3-4% of folks use their cloud because it's not the default. So it's really important for us to just make that super easy.
And can I buy something from you? I guess you are a startup too. You can also sell services. So could I buy the professional edition of Pulumi, or what I will get then?
Yeah, so we have an enterprise and business critical edition. We also have a team edition if you want to, onboard, 25 teammates and have easy collaboration. It's pretty inexpensive, especially to get started because we have a free tier. We have some large customers. Mercedes-Benz, I was out in Stuttgart just not too long ago visiting with a team out there. And so we've got some pretty big customers. Snowflake also is a large customer of ours. So we definitely have an enterprise business critical. There's advanced compliance and security features that come along with that most big teams need.
Yeah, you mentioned Mercedes. Now you have to buy AMG,
Exactly. I visited, I got to see a self-driving Maybach, which I don't know if I'm supposed to say that publicly, but pretty cool stuff happening out there.
Of course, completely provisioned with Pulumi, right? All the Maybach devices.
Joking aside, actually, we are used for all the connected car stuff. So potentially, I don't think I'm allowed to know whether that specific car is Pulumi or not, but it's been great.
At least the onboard watch is Pulumi, Pulumi loaded. Okay, what I'm interested in is how it actually works. So let's say you are on AWS. Are you using the AWS SDKs to provision the runtime, the resources, or how you deal with the cloud?
So it varies for the different cloud providers. We're code generation junkies, so we have a lot of code generation systems to make sure that we provide the same experience across every language. That's how we're able to bring up Java so quickly. It's something we call crosscode, which is a new technology that can basically take a single schema and project it into lots of different languages. So in the AWS case, they have something called the Cloud Control API, which is a metadata-driven, anytime they ship a new service, they publish the metadata.
But this is very new. It was released last year.
That's correct. Yep. And so that's what we're moving to. We've done that for Kubernetes, for Azure, for Google Cloud. That's our preferred model. We can also handwrite providers, which we've definitely done for a bunch of them. We can also adapt any Terraform provider. So if there's a Terraform provider, you can plug it into Pulumi. We take the Terraform schema, project it into the Pulumi crosscode schema, and then you instantly get it from any language. But then ultimately, it's the provider, which is a plugin that's doing all the create, read, update, delete operations using the SDKs, like you pointed out.
But it's actually great because if you use the control APIs from AWS, they are very consistent. So they are really RESTful because the usual SDK stuff is not really consistent. There's no describe and lists is not all resources behave the same. So what it means from if you generate the code, we also get consistent Java experience then because I assume all the resources will look similar. It's a better learning experience for the Java developers.
Exactly. Yeah, it's a great point because we have to work really hard to paper over those inconsistencies when we manually implement. The Cloud Control API just cleaned everything up. We were demoing some of the core Java team members a few weeks ago, and they said, "Hey, this looks like idiomatic Java. This is great because you can just statement completion. You get the full API surface area. I mean, it's just a really seamless experience."
Yeah, this is what I have to say. Now, this CDK from AWS is not really Java-like. I mean, it is consistent, but this class.builder.create is unusual first. So now I just can write it. But at the beginning, it was a little bit strange. And what also you said, the mapping reminds me of, I don't know whether you're aware of, in CDK, there's the project, I think it's called JSII, where they are mapping, JavaScript to JSON and then to Java. That they have and then at the end, everything is CloudFormation, basically. But I think you are operating differently because CDK is like the Java objects are serialized, with Jackson to JSON, and then they become Terraform. What you are doing is, so you are generating from the resources the Java bindings, right? So I'm just indirectly using the control API from AWS, I guess, right?
Yeah, Pulumi is a multi-language runtime at its core.
Yeah.
So it has a type system, a schema, an object model that's agnostic from the cloud and language. So it's not transpiling down to YAML or JSON. A key difference from JSII as well is you can write in any language and then consume in any language with Pulumi. JSII, I believe, you still have to write the component in JavaScript. So if you wrote all your components in Java, but then you had a teammate join or a team on board that wants to use Python, maybe they're the ops team, they can still consume those components from Python, even though you wrote it in Java. We have a lot of our large customers are doing things like that. Also, I assume this is going to be airing after we've launched all this stuff. We actually are launching YAML support, which sounds a little strange potentially.
Now I'm a little bit disappointed, but it's okay. I mean,
most of the time, people's first reaction is exactly that. And then 2 or 3 minutes later, they're like, oh, okay, I can see why this is useful. Because where it comes in useful is like, let's say your platform team wrote everything in Java, and now you have some very simple users who don't really understand infrastructure as code, but just want a simple manifest-oriented way to provision all the stuff that you wrote in Java. Now they can just have 15 lines of YAML, still get all that Java goodness behind the scenes. And so it's really great for these sort of platform teams. Mm-hmm. But that's also a good example where this cross-code thing is a little bit different from JSII.
No, I mean YAML also works. Obviously, if you look at the SAM templates from AWS, they're also simple. They are readable. But if you look at Kubernetes, forget it. In my eyes, I mean, this is way too long. I mean, yeah.
Our first customer, we knew we were onto something when we took 25,000 lines of YAML, CloudFormation YAML. Yeah. Nobody understood it. Their DevOps guy quit. They were sort of in a crisis, and we distilled it down to 500 lines of JavaScript. And we're like, okay, this feels better.
From Java perspective, I assume I get from you a Maven dependency, right? With all the, hopefully one dependency with all the control APIs, right? Or multiple?
You get to pick Maven or Gradle. I don't know if many people pick Gradle, but by default Maven. And so, it's one dependency on the Pulumi core SDK, and then one per cloud, because of course we support over 80 different cloud providers.
Oh, perfect. AWS. But you don't have one dependency S3 and you have just one for AWS and one for Azure, right?
That's right. Because we find
that's great because
versioning is a lot easier kind of that way is what we found.
Yeah, because I don't know whether you remember, but the AWS CDK 1, there was one dependency, per resource. And I said, this is not usable. I cannot just, include 100 dependencies in my projects. And then they switched in CDK v2 to one dependency, and I use it all the time because it's way better. There's just one dependency and go for it. And I get, you need both because you need the core and the... it is okay. So I will have to install Pulumi, on my machine plus the Maven, right? Or will I get with the core Maven dependency the Go runtime as well?
No, that's the nice thing is everything's pre-compiled. So all the Go stuff is just distributed as binaries.
So I install a Pulumi first, and then I get the Maven project, right?
Yep. Yeah, if you go to pulumi.com, you'll see getting started buttons. You click one of those and then just select Java in the language chooser. It'll walk you through the whole thing. And, it's really simple. It's like 7 steps and you're up and running in the cloud and provisioning resources and all this good stuff. So,
yeah. What I don't like about CDK is that the JavaScript or Node controls my Maven project. You are doing this as well?
No. We avoided that. In addition to, because this is why the cloud, the fact that we're ahead of time compiled with Go and everything, it's a multi-language runtime. So we don't depend on JavaScript if you're not using JavaScript as a language.
No, but how this works? So, does the Maven project has a main method? or you Go runtime calls Maven to do something. So I know what is the interaction between Pulumi and Java. So if I would start to develop, let's see, I would like to create a simple S3 bucket. So how this would look like with Pulumi. If you know some pseudo Java code, just say it. So this would be interesting.
Yeah, so you declare package as usual. You import the com.pulumi core SDK, com.pulumi.aws.s3. So you import those. You have a public static main. You can embellish it if you want, but you can just say pulumi.run and give it a lambda if you want, or you can stick that into its own function. But you basically write, because Pulumi needs to set up context for the deployment state and all this. And so within that, then you just say, hey, var bucket equals new bucket. Give it the parameters, like if you want to control ACL, like make it public read. If you want to set up a website, you can set up, the index HTML document, stuff like that. And then you can export the results. If you want, like, let's say you did the website in S3, you might export the auto-generated domain name that Amazon creates for you. And Pulumi, there's a little bit of a YAML file. It's basically a project file that says this is a Java program. And when Pulumi sees that, it knows how to spawn a pristine Java process that loads your program and runs it as is. And so it really is just Java. And there's no strict Maven dependency there, because you can use whatever package manager you want. You can use Gradle if you want. We're kind of unopinionated, although we make sure if you're using Maven, it's just easy out of the box.
Yeah, but your Go runtime calls Java, and Java gets executed. But
that's right.
What does the Go runtime actually do? I mean, because if the Java creates with the control APIs, the state management happens in Go. But then the question is to know how Go receives. So this interests me. So what is the interaction between Go and the Java process?
It's a great question, because this was the key insight we had. We originally forked the V8 runtime and it was all intermingled. And then we realized we could separate these, separation of concerns. The Go runtime handles state tracking, the declaration of desired state, creating diffs, creating plans, executing the plan, doing the create, read, update, delete operations, managing parallelism, because some of these things can happen in parallel. But what it does is it launches the Java program, or the Java runtime, with a little shim that basically just runs your code without much. The one thing it does is it uses gRPC, which is RPC, protobuf-based RPC system that basically allows the Java process to communicate with the Go process and vice versa.
Like so Corba, right?
Basically, yes. Yes. I worked on COM in the early days at Microsoft too, so it's like COM, Corba, all over again. Yeah. In fact, we sort of just recreated COM in many ways.
Yeah, exactly.
But as it's running, when it hits that new bucket statement, it communicates back to the Go process and says, hey, I just allocated a new bucket, track it in your state. And that allows it to interact with the CLI. And we have a thing called automation API, so you can actually run infrastructure as code embedded in a larger program. But in all these situations, the Go process is doing the bookkeeping effectively.
But now I understand it completely, because for me also now, if you generated, the APIs for Java, and I'm communicating already, with the AWS, then the bucket is already there. It's too late, to go to know. But what you did, you are creating compliant proxies, which are communicating via gRPC with the Go. You can recording the state in the Go runtime, and then you can apply it to the AWS account, right?
Precisely, exactly right. Yep.
This is actually a great idea, and this is completely different to Terraform, to CDK even. So this is what I like about that, because before the meeting I thought, Pulumi just another thing, but another completely different thing. And so what it means. So let's say what I also like in CDK is the concept of constructs. So what I do a lot, if I have to use, let's say, fargate or Azure function, whatever Azure functions coupled with these, I think it's called service bus. So you can in Azure you have to have bicep, but on CDK you have a construct, and the Java construct you can what we do, for instance, right? A couple of times, if you have a fargate cluster, I'm defining, I would like to have a microservice, Java microservice. Then I say, okay, cluster, add microservice, and it's done. And the entire VPC and subnets and whatever happens, behind the scenes inside the constructs. I think I can do it easily with Pulumi as well. So I could create reusable Java libraries, push them to Nexus, which is great story because we already have the entire reuse for years in Nexus, and then just pull it to other Pulumi projects, right? And yeah.
Absolutely, that's correct. We have a thing that's very much like a construct. It's called a component resource. And a component resource encapsulates the configuration of other resources. You can have a parent-child relationship between them. And you're right, it brings sharing and reuse and abstraction and encapsulation to infrastructure as code, which was one of the things that struck me is why are we copy and pasting? Every time we set up an Amazon VPC, it's like 4,000 lines of CloudFormation YAML that we copy and paste time and time again. Whereas now you get real sharing and reuse. That's one of the most powerful parts of this.
Yeah, and I actually find that the reuse and sharing usually never works well, except in business projects. But in the clouds, it works really well. And the reason is being because, the APIs are standardized. So, yes. And then my VPC is exactly what you also have to use because we both creating, the same VPC with different parameters. So the reuse for infrastructure is just the killer use case. And what I don't see a lot in projects, exactly what you said, VPC is the smallest part. But if we are talking with, let's say VPC endpoint with Fargate and security groups, and maybe later Knuckles, and then you can even have some security checks. Now there's a huge time saver if you do it this right.
And it prevents you from making mistakes. I can't tell you how many customers we work with, and everybody has to set up a VPC. Like literally every customer doing anything serious in Amazon with something in production, but everybody's doing it just slightly differently, accidentally. And it just allows you to just cut out a whole bunch of undifferentiated heavy lifting that we shouldn't have to go through. And then we can focus on the more interesting problems.
So then something else. So are you aware there is a concept called self-provisioned runtimes, right? So what I like a lot. So what I also tries to achieve that. So I'm obviously I use Java even for lambdas, and so if you works great with runtime like Quarkus or Micronaut, for instance, they are even faster than JavaScript. The thing is, what I would like to have is that the infrastructure as code and the business code are in the same repo. Mm-hmm. And you can do this with CDK, but it's a little bit clumsy because you have to have two Maven projects because of the JSON thing. But I have the feeling with Pulumi it could work in one project because your Java code is just a regular main method. It's not like you have two life cycles. So it's also interesting. I wanted to think about it, so I would try it. So yeah. Cool stuff you did actually. With the Go and RPC, I have to think about it. It's actually a great idea, I have to say.
Yeah, I think the thing you were just mentioning, app code and infrastructure code, that's what we really get excited about because, as infrastructure, especially for serverless applications, becomes much more closer to application code, is a serverless function infrastructure or application? It's sort of in this gray space in between. And I think, building real distributed applications, that's sort of the next horizon for us is how do we make this even better? I mean, it's great that you can use your favorite language, but we still have so much further to go in terms of making it as seamless as, hey, I'm just writing a distributed app. It should be 10 lines of code. I shouldn't have to write hundreds of lines of config. Even if it's in Java, like, yes, it's great that it's in Java, but why should I have to write a bunch of this stuff when all I wanted to do is business logic? It's funny, at J2EE, I remember back in the day, we're like, just focus on your business logic. Just focus on your business logic. And we're still trying to get to that business logic, still to this day.
Yeah, the cool story is with J2E. I just use J2E and I like it a lot because I did just wanted to write business logic. And the cool story is right now, the natural successor of Java E is actually serverless, not Kubernetes. Because, the absolute mindset of Java E and J2E from back then is serverless. Don't care about the infrastructure. Just, focus on focus on business, and this is what I like, whatever is serverless, because I just learned J2E to avoid to learn ATG, JBoss, Tidestone, Gemstones, and all the other stones, and Silver Streams and Bolland, and it was like we had 50 different servers. It was mission impossible to learn them all. So my escape was to learn J2E, and now it's just the same. If I focus on serverless, then it works. And what I also like is the convention of a configuration. So what we do in Java projects, we say, okay, what is a component? Component is basically Java package and has a business name. But if you have a business name in Java package, this package emits usually some KPIs or business metrics. So you can combine them with metrics in CloudWatch. CloudWatch metrics. And you can create an CloudWatch group, log group, which corresponds to the service. So what I mean, we can actually have almost like Rails-like experience with Java, where we create the entire service. And we get out of the box, the right CloudWatch group, the right, the ECR is created with the right name of the service. So don't make me think, just create everything, from the information we already have. And this is why I'm interested in combining, infrastructure as code with the application code, because then you are really effective.
Yeah, honestly, I think I love the way you're talking about it, because I actually think of you think back to EJBs and like RMI, JMX, some of these technologies, it was all about let's connect all these loosely coupled components. Let's not worry about statefulness because it's kind of handled by the system for us. There's inherent concurrency in the platform. We can just focus on business logic. And that really is what serverless is all about. I feel fortunate that I lived through those times, as I'm sure you do, because there's a lot of these analogies. I will say not many people in the industry have. I guess I'm getting old or something, but when I bring up this analogy, very few people it doesn't resonate with most people, but I absolutely believe it.
Last year, I delivered a talk with the title if you like EJBs, you will really like Lambdas, and people thought I'm crazy, but it worked. So I got lots of good questions. So and it's really funny because people said the application servers, and even if EJBs, you mentioned EJBs. If you think about the concept of pools, cold starts, pooling, concurrency, it is almost identical to Lambdas. The main difference is EJBs run in one process and Lambdas are running in multiple processes. So you have to be careful about the semantics of statics. But if you know the concept of EJBs, you are immediately productive with AWS Lambda, which is great story. I just know, okay, this is what I did in EJBs, and this is what Lambda does, which is interesting.
Well, I will have to check out that talk because I feel like I've been a crazy person talking into the wind, but it's great to find somebody who thinks very similar.
Yeah. I will send you the link afterwards. What's also interests me is the control API. So how early AWS publishes the control APIs. So if there is a new service, can you support it immediately or sooner than CloudFormation, or what's the story there?
So support is immediate, which is really fantastic because it's actually an internal requirement now for new services that they publish the Cloud Control API metadata at launch time. And so it's sort of built in that we can support it immediately because, we want to cut down on the lag time. That's the other thing with the Terraform providers. Most of them, all of them, they have a Cloud Control API one, but all the other ones are handwritten. You look at the Azure one, there are bugs that are 4 years old that are, this thing. Humans have to go implement all of it, and we wanted to get away from that. So even Azure, we key it off the ARM metadata. They publish open API specs for the whole API. If you can just reverse it into the resource model metadata, then you can automate all of this. The same thing with Google Discovery Docs. So that, for us, we love that. Not every provider has those, and they're all kind of a little ad hoc, but it is great for same-day support and higher quality.
Mm-hmm. And going back to Azure, so I was excited about Azure because they have the the ARM Java templates language bindings, whatever you call it, and you can program actually in Java. It's this is great, and everything worked. But what I forgot is what I did was not declarative, right? So it was imperative model, and you can only execute it once. So then I found out I was okay, this is really sad, and then I look at Bicep. Okay, so Bicep going in the right direction, but it's a new language, which is great. But I tried something with Bicep. It was not obvious how to use it for the first time. And what means in your case, you maybe did the same. So you are using the ARM bindings in Pulumi, and Go is managing the state for you. So I get the ARM-like language in Java with proper state management, right? On Azure.
Precisely. Yep. So it's more ARM-like than Terraform because it actually is just ARM.
Yeah.
So the ARM resource model, and what that means, by the way, is we can take any ARM template and convert it to Pulumi and give you. So if you have an ARM template, we can take it and generate the equivalent Java for you or Python or whatever your language is. But the key thing you mentioned also is Pulumi is declarative because it's declaring the goal state. That confuses some people because they're like, I'm using an imperative language, but the model, the system is declarative itself. Sometimes I joke and call it imperative. Like we need a name for it. But that's an important key point that you call out.
Yeah, I think the key point is, if you tell people that you are not calling the cloud, you are calling the automation Pulumi engine, and it creates the state, then it's obvious, right? Because
right,
yeah,
yep.
But this is really similar. If you look at the Java ARM bindings on Azure, and if you compare it to Pulumi, so very similar, right?
Yeah, in terms of the programming model surface area, it's just that it's the declarative execution model.
And now an unfair question, because it's really hard to achieve, but can you scan an existing AWS account and create, the state, Pulumi state, and do something with? Okay.
Yep, we have an import command that you can do bulk import. So if you want to import many things at once, you can, or you can import one thing at a time. And import does two things. One, it reads the metadata and brings it into the Pulumi state. And two, which is kind of mind-blowing, it actually generates the infrastructure as code in your chosen language that would have produced that resource state. So let's say you're fiddling around in the cloud console, creating things because you don't know exactly how things connect up. It's very complicated sometimes to know how the building blocks relate to each other. So that's a perfectly fine way to start. But let's say you want Java at the end of the day. Well, now you can just say Pulumi import resources X, Y, and Z, and it will give you a program. And then from that point forward, now it's all under the management of Pulumi.
Okay. I think Terraform cannot do this, and I don't think CloudFormation is also not able to scan existing stuff, right? So this is the now unique feature of Pulumi right now.
Terraform kind of does half of this. You can actually import some of the state, but it won't generate the code for you. And that's right. We just launched Java, and we support generating Java. Same thing with YAML. Because of the way our cross-code technology works, it just by default works in all languages, which is pretty cool.
Mm-hmm. This CI/CD story is you can just run this in code build. I can just repeat it as often as I like. Doesn't matter, right?
Yep. Yeah, we integrate with over a dozen different CI systems. Code build. If you're using Spinnaker, Travis, or Jenkins.
But you don't have to integrate. I just have to run the process. I mean, there's nothing to integrate, right? So what do you need?
Basically, we have some integrations that make it a little easier. But you're right. It's just a program. You can kind of run it anywhere. In fact, I was trying to think back. What was before Jenkins? What do we have? Cruise control? Was that the name of the CI system?
Cruise control, yeah. Anthill, cruise control was there. Cruise control one. The first was the XML based, and then Jenkins came. By the way, the Kozuki Kosuke was also on the podcast. We had a nice chat how Jenkins happened, or actually Hudson. Hudson was the first name, then Jenkins was renamed to Jenkins Hudson. And before Hudson, there was Cruise Control, which was a completely different story. It was XML based, but it was the first, CI/CD. But Hudson was the Sun one, and then Oracle bought it. There were some problems, and they had to rename it to Jenkins.
Yep, that just memory lane, because I remember we used Cruise Control at EMC, and I remember thinking, "Wow, this is like the future. This whole CI/CD thing."
Yeah. So I'm really impressed. I have to say, I like the concept. With that, I'm actually using. So I always impressed by standards, right? And what I don't like, if you invent something which does comply to standard, but in your case, if you are, using the official cloud APIs and you're generating code, So you can say, okay, then I mean, in worst case, say if I don't like Pulumi anymore, I could at least call directly the APIs, and then I will lose the shared state idea. But this is not like a huge risk to me. And in worst case, I learn the APIs because I know now the control. How it's called again? I always forget. Control APIs, right? Cloud Control APIs. What is the
Cloud Control API? Yep.
Yeah,
exactly. That's what it's called.
What was announced last year.
Yep. Yes.
Okay, cool.
It's interesting. DSL, in many ways, you go learn Terraform. It's proprietary DSL. You're not going to use HCL for other things. Whereas with Pulumi, you've got Java. You're using the cloud APIs. Like, there's a lot less risk over lock-in, which is kind of what you were alluding to.
Yeah, and I mean a little bit unfair because Terraform you could also use for the first one what is called Vagrant, right? Vagrant uses also HCL. Packer you could use but I mean it's so trivial to lend the resources, so it is pointless I mean this is like talking about JSPs that we have to learn JSPs. Actually similar to JSPs is Terraform, what I want to say. JSPs without for loops, right? So
right. Yep.
Yeah, cool. Unrelated question. You don't have to answer, but Kubernetes for me it is really interesting. The whole Kubernetes phenomenon, because on premises I think Kubernetes is the killer use case. So you can just run your own cloud on premises, but in public cloud I don't understand it, because if you look how Kubernetes is implemented on Azure or on AWS, it is like cloud inside a cloud, and you have do everything twice. So for me, to abstracting from the cloud in another cloud, I don't get it, and I think it is like maybe if you invested a lot in Kubernetes, then you can lift and shift your Kubernetes environment one-to-one to the cloud, but it's not exactly lift and shift, and it's a lots of code reviews. And what I found out is the entire permissions and everything doesn't work that great in the cloud. So hard-coded credentials, crazy stuff. And even they had to release the CDK for Kubernetes recently, which is another CDK to the actual CDK. So what's your opinion on Kubernetes on public clouds?
Yeah, I think, first of all, we do support Kubernetes. And, one of the things about CDK, like we use CDK for AWS, it's different from CDK for Kubernetes. You're trying to do deployments across the two, like they don't really compose, whereas we have one execution engine. So it's actually quite nice to use Kubernetes on Pulumi. I see what you're saying as well. Like a lot of folks are using it on-prem to sort of just modernize their internal practices and consolidate workloads and move to containers. And for that, it seems great. I think public cloud, it's sort of, to me, it's like a thread pool, right? If you prefer to use a thread pool with its own set of abstractions versus going straight to using threads, like some people genuinely prefer that. It does the resource management, the scheduling. But what you're pointing out, if you're on Amazon, you've got ECS, right? And so most customers on Amazon, if they're just starting, I will suggest using ECS on Amazon because it's just a easier experience. It integrates better with the surrounding services. It doesn't have this like dual control plane thing, which you're alluding to.
Yeah, exactly.
If you're in Google, Kubernetes is the native way to do things, and so that's fine. On
Azure, I would use Azure App Service or the Azure Container Apps or something like this, right? So on Azure, I would also wouldn't use AKS, and if I invested in my own operators, and then of course, or been in product, which is really has to be multi-cloud, maybe Kubernetes. But even if you migrate, Kubernetes from AWS to Azure, I even think that if you would migrate Fargate to ACI or to Azure App Services, even less work, because if you look at the amount of configuration you have to deal with, Fargate is almost negligible. The task is really like 20 lines of JSON, and but this could also actually with Pulumi. With Pulumi, if you could actually technically be able to translate from Fargate to App Service, right? Because they are very similar. I could actually really, no kidding. So I could actually read from. I have a multi-cloud project. You say Fargate and ACI or Azure App Service, which are very similar because really the configuration is really similar. Even I could actually implement this with Java with some translation code, right?
Yeah. Because they are similar. You could probably, create a little abstraction, make it a deployment time decision, which one you're targeting, and absolutely, we see people doing those sorts of things. It's not a panacea. It doesn't work for all services, but for those two, for
No,
Fargate to ACI, really could.
but could I technically use actually drive both clouds at the same time from Pulumi? That I say, no, I'm deploying
Yes.
both, and okay, that's cool.
Yeah, we have a funny demo. It spins up an EKS cluster, an AKS cluster, and a GKE
Exactly.
cluster, and then deploys the same workload, which is actually one of the benefits. Like at least multi-service workloads, the interface is the same. If you're using Kubernetes, but this demo then slaps a Cloudflare worker CDN in front of those and routes traffic amongst the three, and it's a single Pulumi up, and it's deploying Cloudflare, AWS, Azure, Google. I mean, it's pretty magical. Now,
That is
not
cool.
many people will go to that extreme, but it is pretty fun to see it in action.
Yeah, what I think the use case could be, if one company buys another company and they try, to move to unify the workloads, or they have to move it because of license or whatever, this could be a use case. I don't believe, just doing any abstractions between the clouds because it gets too complex. But yeah.
Yep.
Yeah, it was great discussion, I have to say. I learned a lot about Pulumi. I will try it out for sure if Java comes out. So, where people can find you?
Yeah. So I'm Joe at Pulumi.com. Don't ever hesitate to email me. But I'm also on Twitter, Funk of Joe, FUNC of JOE. And then I also have joeduffyblog.com where I habitually underblog. I used to blog quite a bit. But yeah, I'm always happy to chat. If folks want help with their cloud workloads, if they want to know how to adopt Pulumi, if they have feedback on the product, I'm always here. I still answer every email as soon as I get it. So would love to hear from folks.
Thank you, and I really enjoyed the conversation. It was great fun for me. I expected something else. I thought you was like, I don't know, like a Node.js guy. But it was an interesting background.
Yeah, no, thanks for having me on, Adam. I had a lot of fun too. I don't get to relive my Java experiences from early on that often, and it was a lot of fun. Thank you.
And also, the last thing, maybe, my impression is now that Java is taking off more and more in serverless world, which what turns actually out. So what I see in projects is, first, if people recognize that it's actually really easy to run Java's Lambda or Azure function, you just do it. Then with runtimes like Micronaut and Quarkus, you can create coarser grain functions. It means they are larger, almost like a microservice. They are orders of magnitude cheaper than Fargate or Kubernetes. And the funny thing is, if the functions are hot, they execute faster than Python or Node.js. So you can actually save money. And with the tooling, like until the talk, I CDK with Maven combined. This was my choice. Pulumi, at least as good. So you can have prepackaged infrastructure pieces, which makes you very productive. So I think the time is right. I expect to see more and more Java projects coming out, because even Java developers don't even believe that Java can be run in serverless environments. If I show them how fast it actually is, they are surprised and they are really happy that you can pick their own. I don't know whether you know it, but you can pick your own J2E application with JAX-RS and all the annotations, and you run it almost without any modification as AWS Lambda or Azure function with Quarkus or Micronaut.
Wow, that's great. I mean, honestly, the thing that people don't realize all the time is that how much work has gone into making Java efficient.
Yeah.
With virtual machines, hotspot, heavily optimizing JIT compilers and garbage collection that's been highly tuned for server-based workloads. Like, those are important, especially when it comes to warm startup, cold startup, all the challenges we have in serverless. And the funny thing is, like, yeah, sure, there's a lot more like JavaScript frameworks on Hacker News, but there's a lot of people in the world programming Java, getting stuff done. And I think serverless is starting to get to the level of mainstream where I agree with you. I think we're going to see a lot more Java serverless apps in the coming year or two.
And the Java works that well, the standard Java, that we actually use Corretto on AWS, on an Azure, the Microsoft OpenJDK version. And we don't have, the need to use GraalVM to cross-compile the stuff. So it is just fast enough out of the box. And the cold startup times are around 2 to 3 seconds. And if the function is hot, we have response times. If the function we have some dependency injection, but it doesn't happen a lot. So it can be around 5 milliseconds, the response time from a Lambda with dependency injection, entire micro profile with, JSON BCLization, everything inside. In a larger function right now, it is like 50 milliseconds. But this is actually a huge microservice with 320 classes already. Is my current projects. And we have response time 50 milliseconds without, any modifications. And we're running on one core. So we have 2 gigs of RAM and 1 virtual CPU. So this is actually the real numbers. And people are surprised that it works as well.
Yeah, that's amazing. And, just think of the cost savings of going serverless. Like, you're not paying to park a VM to keep those things warm. You're relying on the magic of Lambda and, all of these things to keep things efficient. So I agree with you.
And with Pulumi, even more fun. So thank you a lot.
Absolutely. No, thank you, Adam.